Hi everyone. In previous session, we learned about private IP addresses, and now it's time to talk about public IP address ranges. So, public IP addresses are assigned by the Internet Assigned Numbers Authority, IANA, and Regional Internet Registries, RIRS. The ranges are typically distributed among the various organizations responsible for Internet infrastructure. So it might be a bit, interesting for you that I know some people already bought, individual people that already bought, uh, you know, IP address, public IP address range for themselves, and yeah, it is kind of a business, so they're gonna sell it for a very well price and get too much profit from that. So uh, that's why okay, these organizations are existing, so they look after how these IP addresses range, and registries will be distributed in different areas of the world. So now let's talk about these public IP addresses range. So again, like private IP addresses, we got class A, B, and C for them. Class A is starting from 1.0.0.0 to 126, 255, 255, 255. Again, you can guess it's a very large uh, range of IPs. Class B starts from 128. Why it is starting from 128, you might ask? Because 127 is already reserved for loopback IP addresses. I will discuss about it in this in this paragraph. Class P is starting from 128, 128.0.0.0 to 191.255.255.255. So as you remember from private IP addresses range, you know that this 192 is already 192.168 is already used by class C, so maybe that's why it's actually ended up with this one, with 191.255.255. It means that this is the last IP available in this range. And class C starts from 192.0.0.0 to 223.255.255.255. Okay, you might ask, these private IP addresses are already included in this public IP addresses range. Yes, they are, but you have to actually consider them once you are talking about public IP addresses. So definitely, if you can see, for example, class B might be included in class B of public IP addresses as well. But definitely the 192.16.0.0.0 to 172.16.00 to 172.31.255.255 are not part of uh, public IP addresses. Okay, as I told you before, reserved for loopback IP addresses, these are 127.127.0.0.0 to 127.255.255.255 are already uh, reserved for loopback purposes, meaning they are used to establish communication with the same device. This loopback functionality is essential for network diagnostic and testing. Not just diagnostic and testing, even it might be interesting for you that all the containers inside the pod are communicating to each other via this loopback IP address. So the most common loopback IP address is 127.0.0.1. And I might, let me show you if I've got a available WSL terminal, which is Linux Windows subsystem for Linux. Uh, just to show you where you can find the loopback IP addresses. All right, you just ping localhost. So, okay, see, once I ping localhost, it comes up, it is pinging 127.0.0.1. So this is the local uh, host IP address, which is already assigned to my Windows machine, my actually Linux machine inside Windows. Okay, what are multicast addresses range? These multicast addresses serve various purposes such as routing protocol communication, service discovery, multimedia streaming, and more. And they are starting from 224.0.0.0 to 239.255.255.255. You might ask, what are these multicast addresses? So let me explain you a bit more. So we got unicast IP addresses, we got multicast, and we got broadcast. Now let me make it bigger. All right. So unicast is one IP. For example, you got IP address 1. You are connecting or sending information to IP address 2. Okay, this is unicast. 1, 1, 2, 1. Okay. What is multicast? It is 1, 2, for example, multi or many. So you got one IP address here, one IP address 1. IP address 1 is communicating, for example, with IP address 2, IP address 3, and IP address 4. Okay. So how about broadcast? Broadcast is 1 to all. So IP address 1. What are the broadcast IP addresses in each subnet? It is the latest IP address. That's why it is not available IP addresses to be used. It's using for network communication, stuff like that. So IP address 1 is sending message to all IP addresses, not just IP address 2 or IP3 or IP4, but it is actually going to IPN, the final actually usable IP address in your subnet. This is the difference between multicast and actually unicast and broadcast. Maybe, uh, yeah. So among those multicast IP addresses, these IP addresses range are very common. Uh, the multicast IP address is used mostly uh, in the context of public IP addresses because I already talked about private IP addresses and the latest not available IP address to be used as broadcast IP address. All right, so future use and private use range reserved for future use by Internet Assigned Number Authority, IANA, and this is an international company. And for private networks, so it is starting from 240.0.0.0 to 255.255.255.254. So these range is already reserved for future use. Who knows? Maybe one day uh, they need to be used. Okay. Now we are getting to the main important part, classless interdomain routing. So what is classless interdomain routing, CIDR? It is a method used to allocate and specify IP addresses and their associated network prefixes. CIDR notation is a compact representation of an IP address and its associated network prefix, allowing for efficient allocation of IP addresses and routing on the internet. And here is how CIDR notation works. IP address. What is an IP address in the context of CIDR? An IP address is a unique identifier assigned to each device on a network. It consists of 32 bits for IPv4 or 128 bits for IPv6, represented in decimal format, separated into 4 octets for IPv4, or hexadecimal format, separated into 8 groups of 4 hexadecimal digits for IPv6. Uh, let's have a look to a typical IP address which we've seen. Okay, let me open up a new. Uh, let's open up one of my IP addresses at home. Yeah, the one which I'm going to use for teaching you about Linux machines. Okay. Uh, this is my PC's IP address. Okay. So what is it actually? It is, if I'm gonna show you the in the context of CIDR, it is 192.168.1.5 slash 24. What is this 24 slash 24? Everyone call it prefixes. Some people call it subnet mask because it is actually masking zero and ones. But don't make it complicated for yourself. It's just a prefix number, okay? And it is showing the number of available networks IP addresses, and it is showing in which range these IP addresses is existing. That's all about IPv6. And as I talk about it before, this number is in a decimal format. What is decimal format? As I think that I told you, we like to do talk about numbers in a way that we've been taught from early childhood, and it is decimal contract. I can say it's a decimal convention. So, and it is coming from the number of fingers you have. This is the finger in two hands. See? You have 10 fingers. That's why many people all around the world are using decimal to show you the numbers. So this 192.168.1.5 is decimal. You can show this number in other formats as well, like binary. If you're gonna show it in binary, for example, this 5 will be something like 2 to the 1, 0. This is 2 to the power of 0. This is 2 to the power of uh, uh, again uh, 0. Okay, uh, 2 to the power of 1, sorry, 2 to the power of 1, but since you already put 0, it will be 0 multiple 2 to the power of 1. And this one is, if you put 1, it is actually 2 to the power of 2. So let me show you in more detail. So I just want to convert this 5 to the binary format, which is not too much familiar for you. It comes to 1, 0, 1, then 0, then 0, then 0, 1, 2, 3, 4, 5, 6, 7, 8. See? And this 1 is coming to again 1 and 7, 8. 7 zeros behind that. 1, 2, 3, 4, 5, 6, 7, and blah blah blah. Okay? So how it is coming? All you need to do, you have to add this one. 2 to the power of 0 plus 2 to the power of 2 comes to 5. Yeah, I know it's a bit complicated, maybe, but for people who are familiar with converting the decimal to binaries and hexadecimal to, I don't know, to hex or stuff like that, it's not too much complicated. But don't be that much, fussy about that. We are mostly dealing with this decimal uh, convention, at least in the discipline of DevOps and DevSecOps. So don't worry about knowing all these conventions and things. But if you are interested, as I told you, network engineering is a very vast, discipline. I remember I started network engineering concepts once I was much younger than now, and I still believe that I don't know a lot about network engineering. So honestly, It's an endless discipline, just like DevSecOps. Okay, now let's get back to where were we? Okay, I'll talk about this one. Network prefixes. I told you what is network prefix. CIDR notation. In CIDR notation, an IP address is followed by forward slash and a number representing the length of the network prefix. For example, 192.168.0.24. I'll talk about that. Represents an IPv4 address 192.168.0.1.0 with a network prefix length of 24. So this 24 was here, okay? This 24 is actually 24 bits. So you got 24 subnet mask bits from those 32 bits, and they are fixed, so they won't be changed. Anything after that 24 bits, which are 8 remain bits, could be changed. That's why this network range will give you 256 IP addresses, from which 254 are available. The IP addresses 192.168.1.0 represents the starting address of the network. We talked about it. It is network IP address. The slash forward 24 indicates the first 24 bits of the address are dedicated to the network portion, leaving 8 bits for host addresses. And prefix length, the number following slash or forward slash represents the length of the network prefix in bits. It can range from 0 to 32 for IPv4 addresses, and from 0 to 128 for IPv4 addresses. Or you might say, okay, 0 is a very big number. Where are you going to use 0? Okay, I'll show you. Most of the time here, this gateway, so already got a default route been assigned to that, that's saying, okay, any internal IP addresses comes toward you to this gateway, anything comes toward you, just route them to this range, 0.0.0.0.0. This 0 is a prefix, you can see. Okay, let me make it bigger. Maybe you see this 0 here is your prefix, and it is showing that all IP addresses coming from here will be routed to this one. So we'll be go through all IP addresses in this range. We'll be go, for example, from this interface which is existing here. So you might have a network interface being assigned into, being defined into your router here, and it is actually sending all IP range in this range through this network interface. All right. Sorry, I'm not a very, you know, I'm not a teacher of kind of, using fantasy pictures and stuff like that, honestly. Because I strongly believe these concepts are more complicated to be fantasy, but I will definitely try my best. I already got some feedback from others that try to be more, showing more fantasy pictures. People like it. Anyway. Okay, so CIDR notation allows for efficient allocation of IP addresses and routing on the internet by aggregating IP addresses range into larger blocks. This reduces the size of routing tables and simplifies routing decision. For example, multiple contiguous IP addresses with the same network prefix can be represented by a single CIDR notation, which improves scalability and efficiency in network management. Okay, what does that mean? Let me open up another new picture. Hmm, okay. Uh, Once it's saying it is contiguous IP addressing, you have to know the meaning of contiguous. But for me, all I can say you just need to know that IP addresses should never overlap each other. So imagine you got a router here or a layer 3 switches. So I might show you in future the real uh, routers or layer 3 switches, which I already got in my home lab. But by the way, they are for many years ago, and I don't think so that if even if they are already, uh, I'm pretty sure that their iOS is not, you know, uh, the operation system is not uh, updated for now. But that anyway, just I might show you in for just for the purpose of training. Okay, so you got these range 192, 168. This is a LAN cable. I talked about LAN cables in previous sessions. 1.1. Okay, I'll show like this. This range of IP addresses are here. So for this one, you cannot assign, for example, 192, 168.1 dot, for example, 0-25. And you say, okay, they are not same, so it's a switch. So once it's a switch, it should be it in this case they will overlap each other because the range are same. Although they look different. This one is 24, this one is 25, but since the range are same, they can overlap each other. So you have to know the most important thing, even once we are defining or uh, virtual private cloud. One of the most important thing in AWS or even private clouds is that you shouldn't have IPv4 IP addresses or even IPv6 IP addresses. I will just deal with IPv4 anyway. To be overlapped each other. They have to be in different subnets. They have to be contiguous. Okay. Uh, all right. Again, let's get back to my text. IP address subnetting. This process involves determining determining the number of usable IP addresses within a given range, considering factors such as the network address, broadcast address, and reserved addresses. Okay, I'll talk about subnetting. Uh, in next session. Thank you very much and have a good time.